In this lesson, we'll learn how to calculate probabilities on any normal distribution. And I'm bringing here one of the diagrams from the first movie on this chapter. So imagine we have this distribution, x normally distributed with mean 65 and standard deviation 3, so the variance is 3 squared. And I want to find probability of x smaller than 66.72. So I want to find this area. The big idea here is that the point here and the corresponding point on the standard normal distribution are linked by a formula. When I say corresponding point, it means that the area to the left of this point on the non-standard distribution is the same as the area to the left of the standardized score. So this is what links the two distributions. The two areas are the same. The formula that links these 2 points, the z-score and the x1, is z equals x minus mu over sigma. Meaning that whenever I have x, I can find z. So for x, in my case, x was 66.72, z, the corresponding score will be 66.72 minus 65, the mean of the standard of the normal distribution, over 3. And this will give me, after using my calculator, 0.572. So the point here is 0.572. Calculating probability of x smaller than 66.72 is the same of calculating probability of z is smaller than 0.572. And we saw in the previous movie how we calculate this probability. You can use a table of values or you can use your calculator, and the answer will be 0.716. How we write this, if we want to formalize, we can write probability of x smaller than 66.72 is the same of probability of z smaller than 66.72 minus 65 over 3. Exactly using the formula there. And then I continue with getting the answer from my calculator or from the table of values. If you want, you can write as phi, this one as phi of 0.572. It does not matter in which way you write. My advice is to always rely on the diagram so that you understand and you remember. Once you practice many times, you remember the connection between those two distributions. I will now solve a couple of examples from your textbook. Let's look at question 7a. X is normally distributed with a mean 83.2 and standard deviation 4.5. Find x such that probability of x bigger than x is 0.01%. So this is my x, or 1%, and this is 0.01, so 1%. That's my distribution x normal with 83.2, 4.5 squared. I need to bring this on the standard normal distribution. So I'm looking what's the equivalent of x on this one by looking at the top 1% area. Therefore, I need 99% here. If you remember, I showed you earlier this part of your formula booklet, which is very useful and gives you the faster the answer. So I'm looking for an area of 99% to the left. So my z-score will be 2.326. 2.326 is the z-score here. Therefore, z and x are connected by the formula z equals x minus mu over sigma. Solving this equation, I would find x, which is 2.326 times 4.5 plus 83.2. Let us look at question 8 now. X is normally distributed with 0 and 15. When I see something like this, I know that 15 is a variance, not a standard deviation. Therefore, not so that I don't mess it up during the exam, I would write 0 and square root of 15 squared, so that I remember actually that the standard deviation is square root of 15, so I see it. So that's a way I prefer to write to see it better. Question A. Find H such that probability of absolute value of x smaller than x is 0.8. From pure math, remember that this inequality can be written as negative x smaller than x smaller or equal than x. So probability of x being in between minus x and x needs to be 0.8. That's on the x distribution with 0 square root of 15 squared. It's interesting to see that this interval is centered by x, so you want it to be between minus x and x. And I know that it's centered because the mean of this distribution is 0. So if you want the area in the middle to be 80%, then this area here needs to be 10%, and the area on the other side needs to be 10%. So we need to know exactly the properties of this distribution and the fact that it's symmetric. So I need to move now to a standard normal distribution. So I'm looking for a point that splits me 10% here and 10% on the other side. This one has the same mean 0. It doesn't matter which point I find. One, it's enough. So I can look for that point so that this area here is 90%. And I'm going to use the same table as before to notice that for an area of 90%, which is here, my point will be 1.282. So my z-score is 1.282. Therefore, I'm going to connect this z with this x by z equals x minus mu over sigma. Therefore, x is 1.282 square root of 15. Just to notice, if this area, the pink area, wouldn't be one of these numbers here, I would need to use either my calculator or a table of values. The process is the same, maybe a bit longer. How about this question? X is normally distributed with a mean unknown, so I don't know the mean mu, but I know the standard deviation. So this is my x distribution. Mu unknown, 5 squared. I know that probability of x bigger than 23.4 is 5%. So 5% is somewhere here. That's 5%. And I know now that this point here is 23.4. I need to find mu. I'll still use the standard normal distribution with the 5% here, and I'll find the z-score from the same table. So for an area of 95% on the other side, to the left, my table tells me that 95% is 1.645. So this point here is 1.645. Therefore, these 2 points are related by the same formula. Z equals x minus mu unknown over sigma. And our sigma was 5. Solving this equation, I find mu. So mu will be 23.4 minus 1.645 times 5. Last question that I'm going to take as an example. See, in this question, mu and sigma are unknown. So I know that I don't know mu and sigma. X is normally distributed with mu and sigma squared, but I know that probability of x smaller than 2.1 is 60%. So 2.1 is somewhere here, and that area here is 60%. I also know that probability of x being smaller than 2.7 is 70%, so all that area is 70%. Find mu and sigma. See how now I have two equations, I have two bits of information. I have one bit of information and the other, and I have two unknowns. Therefore, I should be able to form a system of two equations with two unknowns. So I'm looking on the z distribution for an area of 60% here. And I'm looking at this score, which will be linked to 2.1. Now I'm looking in the table for an area of 60%. Let's see where we find it. So it is here, almost 60%, therefore is 0.25. So 0.25, and I'm looking what's missing up to 60%. I'm missing an 1 3 here, and 1 3 is closer to 0.3 here. So it will be 0.253. 0.253. Oops. Therefore, my first equation, these two numbers are related, z equals x minus mu unknown over sigma unknown. So that's my first equation. I have another bit of information from which I can find the second equation. So my second bit of information is that for an area of 70%, I can find a point here. Unfortunately, 70% is still not here, so I still need to look in the table of values. So I'm looking for an area of 70%. Which one is the closest to 70% is this number here, 70%. So 0.52. What I'm missing up to 70% is 15, 1/5. And I find 1/5, the closest 1/5 is this 4. So my answer will be 0.524. 0.524. 0.524. So my second equation is 0.524 equals 2.7 minus mu over sigma. And here I have simultaneous equations. Now it's an easy way to solve the simultaneous equations by multiply by sigma. So you get 0.253 sigma equals 2.1 minus mu. Second is 0.524 sigma equals 2.7 minus mu. If this one is equation 1 and this one is equation 2, if you do equation 2 minus equation 1, then you get mu will disappear. So then we have 0.524 minus 0.253 sigma is 2.7 minus 2.1. Therefore, sigma is going to be 2.21, three significant figures. You always need to get the standard deviation positive. Standard deviation is always positive. Mean can be negative, is a mean of a distribution. So mu from equation 1, mu is 2.1 minus 0.253 times sigma. And this is 1.54 to three significant figures. So this is what I use in the case when I don't know the mean and the standard deviation of the population. And in this case, two bits of information are given, and from the relations connecting the z-score and the x value, I get mu and sigma.